In the second half of the chapter, we're exposed to yet a few more trigonometric identities that we can use to evaluate trig expressions, solve trig equations, and that we can use to verify identities that we've seen in the past. So you have the sum and difference identities there on the screen. Notice that they are also on your reference sheet, so you don't have to memorize them. However, as I've said before, and I will continue to say, do study your reference sheet so that it's not so foreign to you when you're using it. So a couple of things that you might want to notice is that for the cosine identities, notice that I'm taking cosine times cosine and then doing the opposite of the operation inside the parentheses. For sine, I'm taking sine times cosine and then switching them, and I'm doing the same operation as in the parentheses. Notice that for tangent, there's a numerator and denominator, and that in the numerator, I'm doing the same operation as in the denominator. In the numerator, I'm doing the same operation as in the parentheses, but in the denominator, I'm doing the opposite operation. And then in the numerator, it's just tangent of the first angle plus tangent of the second angle, or tangent of the first angle minus the tangent of the second angle. So the more you use these, the more you'll get the hang of them. So in example 1, I'm trying to find the cosine of 15. And what you might realize is that 15 is the difference of, let's say, 60 and 45. So I can use this difference identity. And when I do, I've got the cosine of 60 times the cosine of 45 plus the sine of 60 cosine, sine of 45. And then these values you can find on your reference sheet. Remember, anytime you're taking the cosine, you're looking at the x-coordinate, sine, you're looking at the y. So cosine of 60 is 1/2. Cosine of 45 is radical 2 over 2. Plus, sine of 60 is radical 3 over 2. Sine of 45 is radical 2 over 2. Notice that I'll have a common denominator. So I have radical 2 plus radical 6 over 4. And that's as simplified as that gets. You might want to pause your video for a moment to get everything down. And when you write things down, make sure you're not just writing things down. Pause the video if you need to go back and look at the reference sheet and understand where I'm getting these values from. For part B, it might be challenging for you to figure out two fractions that I would need to add or subtract in order to get 5 pi over 12. So for some of you, you might want to convert this into degrees and then kind of work from there. So let me do that. If I'm converting this into degrees, then I'm multiplying by 180 over pi. So my pi's would cancel out. I would have 5 times 180 divided by 12. And that's 75. And so since in the last example I used a difference identity, I'd really like to use a sum identity here. So what adds up to 75, 30, and 45? Now I want to use the kind of angles that the question used, so I'm going to go back and convert those into radians now. So what I'm finding is the sine of pi over 6 plus pi over 4. So that's sine of pi over 6 times cosine of pi over 4 plus cosine of pi over 6 times sine of pi over 4. And you can't see your identities, so I'll bring those back up. I'm using this one. So now I'll simplify this. Sine of pi over 6 is 1/2 times cosine of pi over 4 is radical 2 over 2 plus cosine of pi over 6 is radical 3 over 2 times the sine of pi over 4 is radical 2 over 2. And again, I know these off the top of my head because I'm old. You might need to pause your video so that you look at your reference sheet and make sure you understand where I'm getting these numbers from. Okay, so this is radical 2 over 4 plus radical 6 over 4, and I actually end up with the exact same answer that I had in the last problem. Radical 2 plus radical 6 over 4. In this example, we're going to work backwards from the trig identity to either find an exact value or just write a simpler expression. So in part A, I'm trying to find the exact value of, and then I'm multiplying some cosines and adding some sines. So this is where studying the reference sheet kind of comes in handy. You realize when you're multiplying two cosines and adding the product of two sines, that is cosine of alpha minus beta. So in this instance, it's cosine of 7 pi over 8 minus 5 pi over 24. So I'm going to subtract these fractions by getting a common denominator. This is now cosine of 21 pi minus 5 pi over 24. So that's the cosine of 16 pi over 24. So cosine of 2 pi over 3. Well, that's just the x-coordinate at 2 pi over 3, which is negative 1/2. In part B, I look at that expression and I notice, well, it looks really similar to a tangent identity. Well, which one? Remember that the numerator of the tangent sum and difference is always the same as the operation going on in the parentheses. So what I mean by that is I can rewrite that as tangent of 6x minus 7x. Well, that means I want the tangent of negative x. And if you look on your reference sheet, it says that when you're taking the tangent of the negative angle, your answer is just the negative tangent of that angle. So that's it. Here we're using these identities, the sum and difference identities, to verify other identities that we saw earlier in the chapter. So I'm going to take the left side of the equal sign and move and shake it, and my sign of x on the right-hand side is just going to pop out. So cosine of a difference is cosine of pi over 2 times cosine of x plus sine of pi over 2 times sine of x. Well, the cosine of pi over 2 is 0, and 0 times anything is 0. So I have 0 plus the sine of pi over 2, which is 1, times the sine of x, and lo and behold, that's what I was aiming for. I have two part A's. How very strange. That's a typo. That should be part B. So in part B, I'm taking the cosecant of something, well, remember that's 1 over sine. So I can say that the cosecant of pi over 2 minus theta is going to equal 1 over the sine of pi over 2 minus theta. And now I'm going to use the difference identity that we saw on the first screen. So that'll be 1 over sine of pi over 2 cosine theta minus cosine pi over 2 sine theta. So sine of pi over 2 is 1. So I have 1 over 1 times the cosine of theta minus, we already talked about how the cosine of pi over 2 is 0. So all of this is 0. So I have 1 over the cosine of theta. And what's that 1 over cosine theta again? Oh, look, it's the secant of theta, which is exactly what I was aiming for. Here, we're verifying other identities along the same lines. So this is a difference, a cosine of a difference, rather. So it becomes cosine of 360 times cosine of theta plus sine of 360 times sine of theta. Well, the cosine of 360 is the same as the cosine of 0, and the cosine of 0 is 1 times cosine of theta. Similarly, the sine of 360 is the same as the sine of 0. The sine of 0 is 0, so all of this is going to disappear, leaving me with just cosine of theta, which is what I was looking for. In part B, I have the sine of a sum. So that's going to be the sine of pi over 2 cosine of x plus the cosine of pi over 2 times the sine of x. The sine of pi over 2, again, that's 1 times cosine of x plus this is still 0. And when I simplify this, I just have cosine x, which is exactly what I was aiming for. Finally, using these identities to solve a trigonometric equation. So I'm going to rewrite this cosine of a sum and this sine of a difference using my identities. Here we go. That's the cosine of x cosine of pi minus the sine of x times the sine of theta minus the sine of x cosine of theta minus the cosine of x sine of pi. I think I may have slipped and said theta. Sorry about that. And all of this is going to equal 0. So cosine of pi is -1. So I have negative cosine of x minus, well, the sine of pi is just 0, so this is gone. So minus the sine of x times the cosine of pi. Again, the cosine of pi is -1. So this becomes negative sine of x, which becomes plus sine of x. And the sine of theta again is 0, so this is gone. So this is my equation. And now I can't get this equation all in terms of sines or cosines because I don't have things being squared. I could square both sides, but let me show you something. If I add cosine x to both sides, I'll have sine of x equals cosine of x. So let's think about this. I'm looking for an angle where the x-coordinate equals the y-coordinate. Get your reference sheet. Where do we see that? We see that at pi over 4, and we see that at 5 pi over 4. And since they were asking for the solutions on that interval, that's just our answer. X equals pi over 4 or 5 pi over 4.